SwayamPrabha. Digital India. Educated India.
Hello everyone, we are continuing from the earlier lecture. So, we are discussing how to internalize the externalities. In this context, we have already discussed what is the cause theorem and how we can internalize the externalities by cause theorem itself. So, today we will be discussing another mechanisms to internalize the externalities, that is the Pigouvian fees, or which is also known as the Pigouvian taxes. So, in this lecture we have planned to discuss what is the Pigouvian tax itself, and we will be discussing what is the optimal Pigouvian tax, and then we will be discussing what are the mechanisms of Pigouvian tax, and finally we will be discussing what are the different issues we are facing in the concept of Pigouvian tax itself. So, let us start with the introduction part, that is our question is how to internalize the externalities, that means how to intervene if there is any case of externalities, so that we need to reach the social optimum. So, in this context, when our target is to reach the social optimum and there is the presence of externalities, what would be the intervention mechanism so that we can achieve this social optimum? That is the questions. Okay. And as we understand that we have already discussed the case of cause theorem. So, what is cause theorem about? It talked about the bargaining power, that is the private bargaining and negotiations, they can help in internalizing the externalities. But if this private bargaining and negotiations they fail, then and the marginal taxes and subsidies are the mechanisms that can help the firms to internalize the externalities. So, the thing that we need to highlight here is that when the cause theorem is not going to be applicable, or when the bargaining and negotiations they fail in internalizing the externalities, in that case this marginal taxes and subsidies they are used as direct mechanisms to internalize the externalities. And in this case we are introducing a concept, a tax concept which is known as Pigouvian tax. So, what is this Pigouvian tax? So, this is a tax that are imposed on the polluter itself who are causing the damages, and this tax is imposed based on the estimated damages or estimated external cost. And when this tax is equivalent to the estimated damage or estimated external cost, such tax is known as the Pigouvian tax itself. So, this concept of Pigouvian tax, it has been introduced by Arthur C. Pigou in his book Economics of Welfare. So, the first edition of the book, it was published in 1920, and he proposed that a tax can be a mechanism or it can be an instrument which can help us equating the private cost with the social cost. So, in the pollution or externality problem, the biggest challenge is that this private cost is not equivalent to the social cost, and that is why there is the problem. And here in Economics of Welfare, which Pigou published in 1920, he proposed a theory that is in terms of taxation. So, there he can use this tax as an instrument, and this tax can be used for equating this private cost with the social cost. So, how it can be equalized? The private cost is equalized or equivalent with the social cost, and we know that in case of externalities private cost is not equal to the social cost, right. So, So that means the private cost in addition to the externalities, that is equivalent to the social cost. So what Pigou proposed, that if the private cost is added with the taxes, or the polluter are imposed with the taxes for the externalities or damage done because of externalities, now it will be equivalent to the social cost itself. So, after understanding this, the very basics of Pigouvian tax, that what is the concept itself. Now, we can say that here in as for the Pigouvian tax, or sometimes we are saying Pigouvian fees itself, the when a farm produces, right, the output and hence produces the any kind of externalities, let us say pollutions. So, it will be imposing a social cost. Pollution is a social cost here, right. And as for this Pigou's suggestions, Pigouvian tax, a per unit tax can be imposed, right, and this per unit tax would be equivalent to the damages from each successive units of output produced by the farm itself. So, here we are saying that what would be the amount of tax, the amount of tax would be the would be equivalent to the damages that are generated from each successive output produced. So, here we are saying that this tax is determined on the basis of the marginal damage cost, that is a per unit tax, or the damages for that is generated from each successive units of output, right. So, the here the damage costs are paid by the farm in form of per unit tax. So, that is why we are saying this tax is equivalent to, or tax is in terms of the marginal damage cost. And when this tax is imposed, that is the marginal damage cost is imposed, right. So, it will be equivalent to your marginal social cost. So, that is why you can say your this marginal cost is equivalent to the marginal social cost when the tax is imposed. So, in this context, we can just need to highlight that, let us say, we just remember that how a particular farm is generating its productions, and the how in the perfectly competitive market how the farm is a price taker. So, now we will be talking about the case of industry and the production, and the case of a particular farm which is producing a product, and simultaneously it is also producing the externalities or pollution itself, right. So, initially as you understand, it is the output axis, and here we represent the price or cost, okay. And accordingly how the price and output is determined, it is depending upon the demand side and supply side functions, right. So, this is the initial level of supply, and this is the demand for the output. So, as a result, we are saying the intersection point, we are finding the optimal level of output and the equilibrium level of price for that output itself. So, based on these, the farm is also a follower, he is just a price taker, or he cannot be a price maker. So, he follows, the farm follows the same price level P0, right. And how the farm's output is determined, it depends upon the marginal cost itself. So, this is the marginal cost of the farm itself. So, when the price line is intersecting marginal cost, so this will be the Q0 output, that is the equilibrium level of output, okay. So, now based on this understanding, now we are saying that a tax is added because the farm is polluting, right, or it is generating some externalities. So, its private cost is not equivalent to the social cost. So, that is why in order to make the marginal cost equivalent to the social cost, a tax is added here, right, in this marginal cost curve. So, because the tax is added, let us say this amount of tax is added. So, because this tax is added, the supply curve of the industry, it will be shifting leftward. So, let us say the supply is shifted, supply curve will be shifting to the leftward. So, now the new supply curve will be S1 S1. So, now we will be having a new equilibrium point. So, by this is the new price level and this will be the new output level, right. So, now as you understand the firm cannot be a price taker. So, it just follows the price whatever is determined by the industry itself. Okay. So, at the intersection point, this is the marginal cost curve, right, and this point where the price and marginal cost curve, new price and the marginal cost curve is intersecting. Okay. So, this point is known as the Q1. So, now the Q1 level of output is produced. So, as a result when the tax is imposed, this is the tax amount. Okay. This is the tax amount. When the tax is imposed in the on the firm, so what will happen? The price is increased from P0 level to P1 level. Okay. And now the efficient level of output for the firm will not be the Q0, rather it is the Q1. So, why we are saying that Q1 is the efficient level of output for the firm itself? Because at this level of output, the price, that is P1, is equivalent to the marginal MC1. So, what is MC1? The marginal private cost plus the external cost, that is in terms of tax, right. So, this is the marginal external cost plus the external cost. So, now it is the marginal external cost, this is the new one, right. So, as a result what we are saying that at this Q1 level of output, this is considered to be the efficient level of output, because this conditions is achieved, that is price is the total cost is internalized in terms of the price and the price is equivalent to the new marginal cost, which is reflecting the external cost as well. So, now you can say the price is equivalent to the new marginal cost, that is equivalent to the marginal social cost, right. So, now we can theoretically understand what is the ideal Pigouvian tax, which is also known as the optimal Pigouvian tax. So, now you can remember the Coase bargaining theorem and optimal externalities. In this context we discussed the optimal externalities. So, there we talked about this is the output or economic activity. Okay. These are the costs or benefits we are measuring in the vertical axis. Okay. And how the optimal level of externalities is decided? By taking into account the marginal external cost and marginal net private benefit. This is your marginal net private benefit, we have already derived. Okay. So, this is the optimal level of economic output. This is the Q level. Okay. So, now how to determine the which one is the theoretical optimal or ideal level of Pigouvian tax? So, now as you understand, in the Pigouvian tax, a tax is imposed, and what is the basis of imposing this term, this tax? That this tax is imposed on per unit of the output, right. So, when you are saying per tax is imposed per unit of output, so now we can say that this tax is T star, because at this is the optimal level of pollutions, right. So, and optimal level of output. So, if per unit of output tax is imposed, so the tax will be imposed, the tax amount would be this much. So, now the let us say this much of tax is T star which is imposed, and when this T star tax is imposed, obviously what will happen, this marginal net private benefit, it will be shifting leftward. Okay. So, now what will be the shape of this marginal net private benefit curve? So, this will be the new marginal net private benefit, which is known as marginal net marginal net private benefit minus the tax is imposed, that is T star. So, here when T star is imposed, T star is the optimal tax, right. And why we are saying T star is the optimal tax? Because it is achieving the social optimum, social optimal level of output and pollutions, right, at Q star level of output, right. So, this is how we learned that from the optimal level of output, how you are finding the optimal level of Pigouvian tax, or what would be the tax that is imposed, which is known as optimal level of tax. So, now the next question is how this optimal level of tax T star is determined. So, here we are saying that T star is determined, or T star is defined at the marginal external cost at this point. Which point? This is the social optimal level of output, that is the Q star level of output. Okay. So, T star is the optimal Pigouvian tax, which is equivalent to the marginal external cost, or here we are talking about the marginal pollution damage at this point, at this particular point, which is the optimal level of pollutions, right. So, in this case we are saying that when marginal external cost is there, what is the cost? Cost is in terms of the pollution damage. So, what is this pollution damage? So, this is a damage functions, right. This can be understood by a damage function, and this damage function tells us two things. One is how pollution damage varies with the level of pollution emitted. This is the first thing. The pollution damage can be varied with the extent or level of pollution emitted, and the second one is the how the pollution damage, it can be varied depending upon the monetary value of that damage, right. So, these two things are explained in this damage function. So, now let us understand this same optimal Pigouvian tax by mathematical representations. Now, you can say that we already know this net social benefit. How we are defining this net social benefit is the gross benefits of the polluting activity, right. So, that means in terms of production itself. So, gross benefits that the farm is getting from producing and also generating this activity, and the private costs, what is the cost the farm is incurring in order to produce the outputs, and for this production what are the external costs that are not included in the private cost itself, right. So, what we are saying that this net social benefit is nothing but the Q, that means the quantity of output produced times the price in the market, price per unit of this output. So, this is PQ, this is the gross benefit of polluting activity in terms of producing the output minus the private cost. So, when this quantity of output is increased, then obviously the cost, private cost will be increasing. So, that is why C is a function of your output. So, likewise minus the external cost. So, again when the output is increasing, the pollution is also increasing. So, that is why your external cost will be increasing. So, external cost is also a function of your Q. So, and here this P equal to price and Q is equal to your output. So, based on this net social benefit understanding, now what you need to do, we need to maximize this net social benefit. Okay. So, how to maximize any functions? Then obviously, we will be saying that we can maximize any function by taking the first order derivative to the 0. So, here the first order derivative with respect to the output is equivalent to, this is defined already in the equation 1, p q minus c of q minus e c of q, right, which you are saying, let us say it is equation 2. Okay. d by dq. So, now after getting this, what you are getting, p minus d del of q by dq del minus del of, okay, this is p, this is del of q, del of c by del q, and this is del of ec by del q equal to 0. This is the first order condition to be 0. Okay. This is nothing. So, now you are saying that p minus del of c by del q minus del of ec by del q equal to 0. So, that means you are saying p equal to del c by del q plus, right, del ec by del q. This is equation 3. What is this? Del c by del q, this is nothing but your private cost. What is del ec by del q? So, this is nothing but your marginal external cost. Okay. So, that means you are saying this price is nothing but the combinations of private cost, marginal private cost and marginal external cost, right. So, that you are saying p equal to, this is nothing but your social cost, marginal social cost. Okay. And from these equations, that is, we are saying from, let us say from equation, this is 3, right, we are saying p minus del c by del q is, p minus del c by del q is nothing but your del ec by del q. Let us say it is 4. Okay. This is price minus the marginal cost. What is the price? It is the benefit to the private firm. So, that you can say the private benefit minus the private cost, this is equivalent, this is nothing but your marginal net private benefit equal to, what is del ec by del q? This is the marginal external cost, right. So, now you are saying this marginal net private benefit is equivalent to marginal external cost. At this point, when marginal net private benefit will be equivalent to marginal external cost, at that point you will be saying you are having the optimal externalities. Okay. So, there you are saying we achieve this optimality conditions. Which you are saying that del of net private benefit with respect to the quantity of output is nothing but del of by del q. Okay. This is equation. So, when you are introducing a tax, so that is equivalent to, the tax must be decided on the basis of the social optimality, right. So, now you are saying that let this T star is equivalent to del of your external cost, right. So, now you can follow this equation, that is P equal to this is the equation 3. So, what we are doing, P equal to, from equation 3 itself, if you are putting the value of T, then del C by del Q plus T star itself, right. So, now we are saying this tax is imposed, and because of this imposition of tax, your this externalities is internalized, and now the price is reflecting or including the external cost as well. We can say that what is the sequence for finding this monetary value of damage, because that is the point that we need to understand in order to have this optimal level of tax. So, for finding this monetary value of damage, what do we need to find? The first of all, we need to identify what is the economic activity or what kind of production the farm is producing, and because of which the byproduct is the pollution itself. So, this is identifying the economic activity of the polluter farm itself. Then next level, after identifying, we need to identify and estimate what is the pollution emission, to what extent. And after finding this pollution emission, next one that needs to be clarified is the concentration of the pollution, whether the pollution is generated and diffused or whether it gets concentrated over a particular geographical area or spatial area. So, again this concentration is going to affect the exposure. So, if the concentration is high, then obviously the exposure will be high. So, this pollution it is leading to the pollution exposure, and this when the pollution exposure is high, then obviously it will be leading to the physical damage of the goods and services or even the health itself. And then we are identifying from the physical damage function, we are identifying the monetary value of damage itself. As you understand, in the physical damage function, we have included both the what is the extent and what is the exposure level. So, this is how we are calculating the monetary value of damage. How we are calculating the monetary value of the damage, that we have already understood from the valuation, non-market valuation techniques, right, rebuild and stated preference methods. For understanding this emission damage sequence that we talked about, we need to understand two concepts. The first one is marginal external cost concept, or what are the components of marginal external cost and what are the components of marginal net private benefit, right. And as we understand, in case of the firms, we are facing this problem, that is the commercial confidentiality of information. Because of this problem, because of this issue, we cannot actually get adequate information or the information related to the composition of this MEC, right, marginal external cost and marginal net private benefit. So, because there is a problem of getting the information about the MEC and marginal net private benefit, therefore, it is sometimes argued that when the government or any government agency, it is acting as a regulator, let us say, for regulating the pollution itself. So, they may not be in a very strong position to extract the related information on the MEC and marginal net private benefit. And because now we understood that there is an asymmetry of information itself, because the polluter is having the information, whereas the regulator is not getting adequate information from the polluter itself. So, this is because of which it is leading to the objection if the government is acting as a regulator or government is proposing any kind of intervention in order to internalize the externalities. So, before going to address the issues of Pigouvian tax, we can now address the case of this optimal Pigouvian tax, right. We are saying that how to mathematically represent the optimal Pigouvian tax. So, as you understand that marginal this net social benefit is this PQ minus CQ and EQ, right. So, how to find the optimal? Then obviously, we need to maximize, okay. So, based on this understanding, now we can find out, what we have discussed? We have discussed how to find out the Pigouvian optimal level of Pigouvian tax theoretically and also by mathematical representations. Now, we can find out what are the issues of Pigouvian tax, what kind of issues and limitations we are facing in Pigouvian tax itself. So, broadly we will be now discussing two types of issues. The first one is the Pigouvian tax in terms of the property rights. When property rights are defined or in presence of property right, how this Pigouvian tax is functioning, right. So, now we can draw this, that how this Pigouvian tax is going to function in case of the property rights. Okay. So, this is as usual we are trying to find out the optimal level of. So, this is your output and this is your costs and benefits. Okay. This is your marginal external cost and this is your marginal net private benefit. Let us say this is 0, this optimal level is known as the Q star level, that is optimal level of output. This is let us say Q pi or Q max, right, point. This intersection point where marginal net private benefit is intersecting with marginal external cost, it is equivalent, leading to the optimal level of output and pollution. So, this is known as B. And this is C, right. Now, we will be looking to that this is the optimal level of output to be produced. So, if but initially if you are assuming that the polluter has the property right, then obviously the polluting firm will prefer to produce at this point, that is Q max, Q pi or Q max point. So, when the firm or the polluting agency is polluting at Q max or Q pi point, then the total pollution tax, right, would be how much, because the firm is producing at this point and simultaneously we are saying that when it is producing, it is also producing not only the output, but also the externality or pollution itself. So, as a result, what the polluter will be doing, the polluter is imposed with a tax or a tax bill. So, how much of the tax bill is imposed? So, for if the producer is producing at this Q max point, then the total tax bill that is paid by, that is to be paid by the firm itself, it is the total area O, B, D, Q star, this area plus Q star D, E, Q pi area, right. But if you see, if you will be looking closer, then you will be finding that for this much of tax bill, right, this much of the tax bill, it is not feasible to be paid on the part of the firm or the polluting agency. Why? Because this tax bill, that is Q star D, E, Q pi, is more than the net private benefit. What is the net private benefit? Net private benefit curve is this much. So, that means if the producer is producing OQ pi or OQ max level of output, it is having the benefit of this, right. However, it has to pay the tax of this. So, that means it is simply not feasible on the part of the producer to pay the tax bill of this amount. Okay. So, as a result, what will happen? In order to avoid this tax, the producer will be decreasing its output from Q max level to Q star level, and this is the theoretical thing that we are also anticipating. So, the pollution or output now will be reduced to Q star level. Even after reaching the Q star level, the polluter is still paying this amount of tax bill O, B, D, Q pi. And even though we are saying the firm is producing at the optimal level of pollution and optimal level of output, but still it has to pay this much of tax bill. So, if you observe this case, then you will be finding that it seems the polluter is penalized twice. How the polluter is penalized twice? The first, it is forced to cut back its production from Q pi or Q max level of output to Q star level of output, right. And the second one, even though the polluter is producing at the optimal level of pollution and output Q star, it has to pay a tax bill of OBD Q star, right. So, which in this context we are saying it is a issue, it is an issue which is related to the fairness, right. And some of the other challenges or issues that we are talking about is that for identifying and estimating this proper Pigouvian fee, we need to find the monetary value of the damage at the optimal level of output, and we have already shown that what is the stages or what are the process for which we can calculate the monetary level of damage itself. And if at all this monetary value of damage and is set, is estimated, and the Pigouvian fee is introduced, generally this Pigouvian fee are levied, it is imposed on the emissions or the ambient concentrations, and both these emissions and ambient concentration, it is measured in terms of physical units, not the damage units. So, that means we cannot actually assume emissions and concentrations, they are related in one to one fashion, right. So, they may there may be difference between these emissions and concentrations in the context of geographical locations. So, in this context what we need to take into account in order to set this proper Pigouvian fee is to consider the assimilative capacity of the nature, because emissions may be different and the concentration may be different depending upon the assimilative capacity of the nature, right. So, now let us look at what is the assimilative capacity of nature and how this Pigouvian fee can be charged in the presence of assimilative capacity of nature. Okay. So, now what we are saying that even though the pollution is there, there is the nature's capacity to assimilate some portion of this waste. Naturally the waste can be assimilated, right. So, that means its physical effect is not effective, or it is not going to affect any kind of harm, it is not going to affect negatively. So, that is what is defined as the assimilative capacity of the nature, which is the nature's own capacity to assimilate and correct the waste. Okay. So, we can actually do this. In the presence of these, we are saying this is the output level and this is your costs and benefits. Okay. And this is as usual, this is the marginal net private benefit curve. What we are assuming earlier is that the marginal external cost, it was starting from zero origin. That means, we are assuming that when the output is generated, output is produced, then automatically the externality is produced, right. But now as you are assuming that the assimilative, we are taking into account the assimilative capacity of the nature. So, that is why, and there is some extent this externalities can be corrected by the nature itself, which is known as the externality assimilative capacity. That is why the marginal external cost, it will not be starting from zero origin, but from here, right. So, this is the level where if at all any externality is produced, it will be corrected by the nature itself by its assimilative capacity. It is not going to harm or damage anything. So, now the shape of this marginal externality curve, this is okay. This is the Q star, this is the Q pi or Q max, you are saying. This is, let us say this is assimilative capacity is denoted by A, this is B, this is C. Okay. and we are also displaying below this 0 axis, we are also displaying the emissions level. Okay, this is U1, and let us say this is U1 of emissions. We are representing the emissions itself, and here we are assuming that the environment itself, it can assimilate the waste, right, up to the emission level E1. That means, if the emission level is E1, then the nature can assimilate it itself. So, after this point of this A, if further emissions are generated, then obviously it is going to affect the physical change, and as a result the economic damage can happen. So, now we do understand that this marginal external cost is drawn, and now what you are saying that in presence of the assimilative capacity, how this Pigouvian tax is going to function, right. So, now you are saying the tax is imposed. What is the tax is imposed? Which tax? This is the tax, let us say T star amount of tax is imposed. Why you are saying T star is imposed here? Because the Pigouvian fees is always fixed, is charged on the optimal level of output. So, that this is the optimal level of output. So, that is why this at this point the T star is imposed. So, as a result, the what is the tax bill? The tax bill would be the O A C Q star amount. So, this is the tax bill that a farm needs to pay, right. And even though there is no impact on the emissions, because till OA level, even though there is emissions, but there is no impact, but still the farm needs to pay this O A B and capital A amount of tax. So, what you are concluding, that even though this level of pollution is not producing any kind of damage, but still the farm needs to pay this tax. So, it leads to unfairness in the tax imposition itself, and therefore, this tax may be called as the use of scarce resources, not use of the environment itself, right. So, what we are saying, that at this level of output, OA level of output and pollution, there is no damage, and from A to Q star level of output and pollution. So, it is, you are saying that this is optimal damage, and beyond this Q star to, if the production is happening from in between this point Q star to Q pi or Q max, it is known as the non-optimal damage. These are the suggested readings for this Pigouvian tax or Pigouvian fees. You must go through chapter 6 of this book, and you can also refer to this book, Environmental Economics and Introductions. Thank you very much.